Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we are going to learn and implement data structures and algorithms using Scala functional programming approach. In our previous videos, we had seen best time to buy and sell stock with at most one trade. In the first video, we calculated the max profit, that is 6 minus 1, which is 5. In the second video, we calculated the max profit along with the index, that is the position of buy and sell. So we zipped the value of our price and we calculated a price with index, which is basically the price along with the day on which the trade that particular price was. And accordingly, we finalized our trade. Now let's expand our problem statement. Alright, I have already commented out the print statement for this video. So the use case here is find the max possible profit with max possible trade. So we have two things to do. First, find max possible trades where buy first, sell later. Second, find the second is find the max possible profit. Alright, now let's implement this. So we will leverage the same price list as before, but we will enhance this to increase the complexity of the prices. Let's name it as price list. Let's create new value 3 and 9 here. Alright, so let's create a case class called trade, where it is going to be buy first. So it is going to be option of int with the default value as none, because there is no trade, it's going to be always empty, no trade, nothing, so it is going to be none. Same thing we will be doing with the sale. So second value is going to be sell, which is again initialized to default, so it's going to be option of int. We are using option of int to make it null safe, and the default value is none. Again we have the profit is the third element, which is another int. So if there is no buy, no sell, there is no trade, profit is 0. Alright, let's calculate the trade list, which will hold the value of all the trades that we are performing, which will be traversing through the price list dot fold left. Alright, which will have an empty sequence of type trade. Let's put it trades comma price. Now let's implement a pattern match on trades. So it will be case nil, where it will be trade the first value, because there is no trade, so let's add something. Let's add the first price as the first trade and append it to our trades. Alright, now when we have something to compare, let's split the trade into trade and the rest, and let's implement a pattern match on it. First we need the value of buy, that is going to be trade dot buy, because we need to compare this with the value of price. It's going to be trade dot sell, and then let's implement a pattern match on buy comma sell. Alright, so we are doing this, we will be comparing this to the price. Let's have the first value is sum, because the buy and sell are sum, so it's going to be sum of buy and sell. Now watch closely, we are going to implement a pattern match and we are going to compare the price if first case is price is greater than b. So if the new price is greater than the price of initial trade, the buy, and the price is greater than the sale. So it means that we are going into upstreak. So we add that sale value here. Let's So there is no change in the buy, but the sale will change. Now the sale will become the new price, and there will be a new profit. So profit would be price minus B. Alright, this will be appended to our rest. What we are doing is we are replacing the existing value of the trade where we had the sale as S with the new price, because new price is higher than the trade. If this is not the case, if suppose we have the price that is higher than B but lower than the sale, it means we have to close it and create a new trade. So the new value of the new trade will be the new price, and it will append to the trade itself. So it will append to the trade itself. All right. So what we have done here is, if we have the price which is greater than the buy and greater than sell, we will change the sale. If not, then we are just appending to the trade. Now the second case is if there is just a buy and there is no sale. Same thing, we are going to compare the price, which is if it is greater than buy, then it means that we can accumulate, or we can change the sale, which is actually none here. So buy is going to be same and sale is going to be the sum of price, and the profit is going to be price minus B, and we are going to append it to our trade. All right. Now else we are going to add this value as a new trade, because now the thing is, the value that we have targeted, which is actually not lower than the sale. So our buy was initially higher and the new price is lower, so we move it. Now the buy has changed. We are replacing the initial buy with the price in one line, as you say. So the bottom line is it's going to be new. So this will replicate something when we have initially 7 and then we receive 1. So the final value would be 1, because 1 is going to replace the 7 as a new buy. Now at the end we have the final case, that is the default case, which means whatever happens, if nothing matches, then it is going to be a trade with it's going to be a new trade with the new price. All right. And it is going to be trades. Sorry, I think this should be here. All right. All right, let's see if we have implemented it correctly. Let's print it for each and then println. Now expectation is we will get all the trades possible with the minimum buy and maximum sale, and then we will calculate both the requirements, that finding the max possible value and finding the max possible trade. All right, so it is running now. Fingers crossed. All right, let me run it again. All right, so I had to exit the presentation mode to see the output. This is the output that we see. So if we compare our initial list, that is 715264. Wait, let me copy these values. 7152. All right, I got it out by mistake. So the value is 71526439. So the first trade happens at 1 when there is no value, then it meets 5. So 7 is replaced by 1 now, then it meets 5. So the second value is 5. It sees there is a profit, it captures it again. 2 comes in, and 2 is definitely higher than 1 and lower than 5, so it is considered as a new trade. So 2 is entered with none as value, where none will be no sale. Again it meets 6, so the sale happens and the profit is booked. Again it encounters 4, so 4 was there like 7, but again it was replaced by 3 because 3 is further lower than 4, and then sale is happened on ninth. So now we have the trade list that we have. Now out of this we need to get the max profit, so we can mark it as max profit as the trade list dot map. All right, first we need to filter the, or we can filter, or directly we can do the map. 0 is not going to make any difference. Underscore dot profit. All right, then we are going to reduce and we are going to add the profit. Now let's println max profit is all right. Now let's run it and see whether we are getting the maximum profit. All right, so maximum profit is 14. So how it is calculated? 6 plus 4 plus 4 is 14. Now we need to know how many trades it took for getting this max profit. So how we can do that? Let's use the trade list again. So let's name it max number of trades. So it is going to be trade list dot filter not, where underscore dot profit equal to 0 dot count, or we can say dot length, and let's print it. Say we can say the max number of trades is max dollar max number of trades. All right, let's run this and see whether we are getting the expected number of trades. All right, so max number of trades are 3. So 3 as in 1, 2, 3, and max profit is 14. So this concludes the max profit with the max number of trades. In the next video, we will see how we can improvise this, and with the given k number of trades, we can get the max possible profit. If you enjoyed this video, please like and subscribe, and see you in the next video. Thank you.